All right, here we go. 3.4. We're going to be using similar triangles. So basically, the main thing we need to know is that when two angles in a triangle are congruent, that means that they both add up to the same number. Therefore, the third one, obviously, I would subtract 180 minus that, and you would get the same number every single time. So basically, if two angles are congruent, the third is congruent, and therefore they are similar. So if you remember similar, we talked about similar in 2.6 and 2.7. So that you might need to remember some of that once we figure out if these things are similar. But again, if we can prove that two angles in a triangle and two different triangles are similar, then the third would be similar. For instance, if we only knew 65 and 20 and 65 and 20, well, obviously 180 minus 85 is going to give us 95, and then therefore 180 over here minus that same 85 is going to give us this 95. So if this was the missing number, it obviously has to be that. If you note, so if I knew the two yellow ones were the same, the third one has to be the same because it'd just be 180 minus that number. So hopefully that makes sense fundamentally. Now let's apply it. So tell whether the triangles are similar. So we look over here and we see that this one has 75, 75, 50, and 50. So we know that X and Y are also the same. So this one is a big yes. To save time, I just left their work over here. But what you would do over here is they didn't show us the same one, but we know that this one's 90 and this one's 90. So this and this are not the same, but maybe this is 42 or maybe X is 38, right? So if that were the case, then they would have 2. So we just, because actually these 38 and X are the corresponding angles here. So what they did was they found that X was 48, not 38, so this one would be a no. Okay, so in this one, we have two triangles. So we have this inner triangle, and I can tell you right now that they love these in standardized tests. I feel like I've seen these a lot. So we have the red and the blue triangles, okay? So there are two triangles, they're just kind of connected. So we have to prove that two angles are the same. Well, obviously the blue and the red angle here, they share that angle, so that one's the easy one. Okay, so now we're going to use the angles from section 1 to prove this. So I kind of feel like they were giving us a hint when they told us that these are parallel lines. So if these are parallel lines, and those are definitely not, but if those are parallel lines, then they are intersected by this thing right here. Therefore, let's see, therefore, this angle is if we do our circle, is the left, and this angle is the left corresponding angle, right? So if we did our big circle around both, this would be the top left and the top left. So those are corresponding angles. So due to corresponding angles, those are also congruent, therefore yes. Okay, so we had this one that they shared, so this is 1. And then because of corresponding angles, this is another. Okay? Okay, lastly, we're going to use indirect measure, which is using similar figures. So we're actually going to use the similar figure, what we've been doing so far in a real life situation to find. So basically, we're over here, we're this guy here, and we're trying to cross this line. We're trying to cross here at X. Okay, we're trying to cross the river. Now, it's obviously not going to be as easy to measure across this river. So this is a situation where we've taken some measurements on solid ground. So we figured out that from here to here is 50. So this whole section was 90. And we'd measured here that this is 90, or this is 60. And we've also had to have made sure, they don't say this in here, we had to make sure that this and this path we're crossing are parallel. Otherwise, this doesn't. This is not going to work. So these are parallel. They're corresponding. So what we're trying to do is find these. We're making these similar triangles. So in order for them to be similar triangles, we had to make sure this was 90 degrees and this was 90 degrees. Therefore, these are parallel, right? And we also need to make sure that two other angles are similar within these triangles, so that we have similar triangles, and then we can use them. So these two here are vertical angles. Therefore, they are congruent. Therefore, we have two. We have these 90 degrees, and we have now these two vertical angles that are the same. Therefore, these are similar. So since we know that these are similar, we can set up our proportions. So if we look at, we're going to look at the, we'll call this the top and the bottom triangle. So the top, we have to figure out what are the corresponding sides. So this corresponds to our distance here. So we're going to start with 60 over x, and that is going to be equal to this top triangle that is going to be that corresponds to this part of the other one. So that equals 50 on the top one, 40 on the bottom one, and now we're going to cross multiply. And so we get 60 times 40. 60 times 40, which is 24. So 2400 is equal to 50 times x, which is 50x. And now we're going to divide by 50 on both sides to get x by itself. And 2400 divided by 50 would be, let's see, what, 48? Yeah, 48. So the distance across x is 48. All right, hopefully all that made sense. Come see me with questions. Thanks.